Hello students, I am Ajay Karmarkar. Before starting video, I would like to tell you something. Please sit with copy pen. If you find somewhere important, pause the video, note it and proceed on. If you find somewhere difficulty, then please write in comment box. I will definitely solve your problem. And along with, please like, share and subscribe my channel that can reach more and more students. Thank you once again.
Now here is the question. A solid body rotates with deceleration about a stationary axis with an angular deceleration beta directly proportional to root omega, where omega is its angular velocity. If at the initial moment of time its angular velocity was equal to omega naught, then the mean angular velocity of the body averaged over the whole time of rotational till it comes to rest is omega naught by n, where n is. Now this question is based on mathematics and formula. Okay, which formula? We have using here the formula average angular velocity is equal to integration omega dt upon integration dt. Okay, so here we have using to solve this question this formula, and this formula is nothing new because we have generally used, for example, average velocity. We know that average velocity is total displacement and total time t1 t2 t3 and so on. So in the place of displacement it can be written as velocity into time v1 t1 v2 t2 v3 t3 t1 plus t2 plus t3. So in the form of integration v is a function of time, then it can be written as v dt upon integration dt. So like that we have using this formula. Okay, so first of all we have given deceleration, angular deceleration beta is proportional to root omega. This is given condition. Okay, and this is angular deceleration means minus d omega upon dt. Why minus? Deceleration. So here we have taken minus, removing this proportionality symbol equal to k root omega. Okay, then minus this value root omega transposing to the left side comes in numerator, 1 upon root omega d omega equal to k dt. Okay, now integrate both the side. Root 1 upon root omega can be written as omega raised to power minus half d omega integration k dt using the limit here omega naught and omega 0 to t. Then integrate here omega raised to power minus half plus 1 minus half plus 1, upper limit omega, lower limit omega naught. Similarly k integration of dt, that is t, upper limit t and 0. Okay, so here minus omega minus half plus 1 means half upon half upper limit omega, lower limit omega naught is equal to kt. This 1 by 2 reaches 2 in numerator, 1 by 2 omega omega naught equal to kt, or it can be written as 2 root omega, omega upper limit lower limit omega naught equal to kt, minus, now substitute the limits, 2 root omega minus 2 root omega naught is equal to kt, multiplying minus, minus 2 root omega minus minus plus 1, 2 root omega naught equal to kt. So here minus 2 root omega, now transposing this term, minus 2 root omega naught plus kt. Here minus 2 root omega minus 2 get common, then root omega naught, and this is minus kt by 2. Okay, because here minus common, so minus 2 cancel out, then root omega is equal to root omega naught minus kt by 2. Okay, now squaring both the side. Here root omega square root omega naught minus kt by 2 whole square, then omega is equal to root omega naught minus kt by 2 whole square. This is consider first equation. Now instant time t, the angular velocity becomes 0. So here at the instant time the omega angular velocity becomes 0. In that case 0 is equal to root omega naught minus kt by 2 is equal to 0, then root omega naught is equal to kt by 2. Okay, or it can be written as 2 root omega naught by k is equal to t. Now using the formula, previously we have discussed that average angular velocity integration omega dt and integration dt and limit 0 to t, instantaneous time, initial time, that is 0, and we should have to be put the value of directly t 2 root omega k, but become complicated, and we have substitute the value at last moment. Okay, so now substitute the value of omega only that we have required. So what is the value of omega? From this equation, omega equal to root omega naught minus kt by 2 whole square. So substitute this value in the place of omega, root omega naught minus k t by 2 whole square, integration coefficient dt, and this is dt 0 to t. Average angular velocity expanding by using the identity a minus b whole square, that is a square means root omega naught whole square, that is omega naught, minus 2 ab, that is root omega naught kt by 2 plus k square t square by 4, integration dt and 0 to t dt. Now average angular velocity and differentiate with respect of t. Now it become omega naught t minus root omega naught k t square by 2 plus k square t cube by 3 and 4, that is 12. Limit here 0 to t, and dt, that is t and 0 to t. Here always when 0 and that is t and substitute the same value, we will get the same result. So is nothing change. So it can be written as omega naught t minus root omega naught k t square by 2 plus k square t cube by 12 upon t. Okay, by after substituting the limits. Here t get common and cancel out by this t, so get the result omega minus root omega naught k t by 2, because one t is cancel out, and similarly k square t square by 12. Okay, and now substituting the value of t from this condition t equal to 2 root omega naught by k in this value of t. Okay, so here average angular velocity omega naught minus root omega naught k by 2, and what is the value of t? Here 2 root omega naught by k plus k square, and now what is the value of here t square, means squaring both the side, 2 square that is 4, root omega naught square means omega naught, and upon k square, and this is 12. Okay, so here omega naught, here k and k cancel out, 2 and 2 cancel out, root omega naught multiply, that become omega naught. Here k square cancel out, 4 ones are 4, 4 threes are 12, means omega naught by 3. So omega naught cancel out, the average angular velocity omega naught by 3. In our question we have given omega naught by n. So compare with this condition, here n equal to 3. So our correct answer n equal to 3. I hope so you understood this question.
Thank you for staying till the end of this video. Definitely, when you will become success, whole contribution goes to your hard work. But if my videos, my lectures, my questions will help in your success, I will consider myself lucky. Please like, share and subscribe my channel that can reach more and more students. Thank you once again. Take care. Bye bye.